So, welcome to our session, Analysis and Visualization. We have 3 talks in the session, and we are starting with Ihda, who will talk to us about Adamant and how you can use it to have metadata stored for your structured experiment. So, the stage is yours.
Thank you for the introduction. So welcome from my side as well. So I'm going to talk about, like the chairperson said, Adamant. It's a tool that we developed in-house at INP Greifswald, our institute. So how we use it to get the structured experiment metadata. And I'm going to talk about the current state of the tool and also the plan future work for future development. And we developed it in this project, within this QPT project, and it's funded by the BMDF. So we acknowledge the funding provided by them. Yeah, right. So maybe just to kind of introduce the institute first, because it can be a bit confusing later on, because we are dealing with like plasma, but often you will just, when you hear about plasma, you think about blood plasma, but that's not what we are doing. So this Leibniz Institute deals with plasma science and technology and its physical plasmas and its basics and technological applications of these physical plasmas. So maybe we start with the motivation why we need this tool, like a statement of need. So in our field of research, this plasma science and technology, this whole thing consists of this multidisciplinary research. And we have like different unique experiments set up, so it can be different from group to group, although that we're still doing this plasma research. Not only physicists, we also have like biology people that works applying these physical plasmas into biological substances. And there are so many interactions as well that we have to kind of record or document how this plasma interact with this biological surface or a solid surface, and so on and so forth. And unfortunately, it's really hard to compare and validate these different experiments because, often the documentations are not really complete, and many of the researchers still also use like physical lab notebooks. So when we started, we came up with an approach which consists of ELAB FTW. This is like electronic lab journal, and Adamant, which I will explain later. So for ELAB FTW, it's an open source lab notebook. You can self-host it at your institutional server. And also it's really generic because I mentioned that we are really multidisciplinary, so we have to accommodate to physicists and also to biologists and other groups in between. So we opt for this ELAB FTW because it's generic, so mostly it's just provide free text with other nice features. Unfortunately, because it's really generic, there is kind of like a limitation in terms of our ability to describe the experiment metadata in a more structured and machine-readable way. So that's where Adamant comes into the picture. So in a nutshell, Adamant is just a tool to document your experiment metadata in a structured way. It's a browser-based tool. Hopefully it's really user-friendly so that users can just simply use it without any hassles. We developed it using this React.js framework. And also, it's based on this JSON schema standard. So basically, you describe your experiment setup or metadata using this JSON schema, and then you use Adamant to render this schema into like interactive forms so that you can fill it and then submit it into like any other tools that you have within your research data management workflows. And in this case, we have like provide like a simple API using Flask that connects it to ELAB FTW. And yeah, just to kind of have like a general overview how Adamant works. So we have a JSON schema that describes your experiment. This is just like a demo simple schema, only a few fields described here. So we browse or select it into Adamant, and then we click render, and then you get the web form. And you can just fill it already, but you can also edit it using this edit panel. If you see in the slide and the field here, you have like different buttons like edit or delete, or to arrange the structure. If you're satisfied, you can fill it and then submit it to different RDM tools like Ihda FTW or other RDM tools. And what's nice about Adamant as well, because it uses this JSON schema, it handles this input validations. If you know, in JSON schema, you can have different types. You can define different types for each field, like integer, Boolean, strings, arrays, and so on and so forth. And it also comes with this validation, so you can ensure that the input that you, the data that you input are correct as possible. Yeah, and we have developed like a couple RDM workflows using Adamant. First is to get this structured experiment metadata, like I explained already earlier, using Adamant, and then connect it to Ihda FTW, and then you get your experiment data from your experiments, instruments, and then you just bundle it together, and then you get a more well-described and machine-readable experiment documentation. And another thing is to have a more automated publication of your data set. So you already have your metadata stored in the Ihda notebook, you have your data, and then you can use Adamant again to connect it to some research repositories. And in this case, at least for plasma science and technology, we have 2 available repositories already, like here. And at some point, we also tried to implement a blockchain functionality to ensure the whether your data actually belong to you, because you get like this the hash and then stored in the blockchain, so you can at some point prove that this data belong to you or to your group. But we're not going to talk about this in this talk. Now coming to the concept. So before it was like really the production-ready workflows. So we also plan to integrate Adamant with ontology or knowledge graph. So we're still building the ontology, at least for our domain-specific knowledge. So hopefully with this ontology, we can have a more like a modular schemas, and then have a more community-approved schemas as well. And we can use the existing metadata that exists in the knowledge graph, and also to have later on maybe an automatic suggestions to create your experiment. If your experiment is really like new, nobody has done it before, so yeah. So it's just kind of show how it could work in the future. For example, you have this not read it from here, so plasma target, and then you have these corn seeds. So this is for plasma application in agriculture. So this ontology in the back end and knowledge graph will kind of suggest like which fields you should add in your experiment. Like for example, what are the relevant diagnostics, the amount of the seeds, and so on and so forth. And the next is to use your existing metadata. For example, you have a plasma source, device that generates the plasmas. And if you say start typing like the name of the plasma source, it will already kind of infer, whether you mean this device like pen something. And you can also like hover around and then have like a descriptions, and then if you go to this like question mark, it will explain why you are being suggested these instances. So these are the concepts regarding the ontology and knowledge graph. And one of our colleagues that is working with Adamant as well, he actually implemented this, creating this graph data using JSON data coming from Adamant. It's possible because, yeah, the metadata itself is machine readable, it's JSON based. And in this case, it's a really simple graph actually that tells which experiment using what device is done by which researchers. And this is just to illustrate how it might look like. And we want to have like this kind of feature as well in Adamant later on, so that people can just browse using the graph for this kind of relationships. So to implement these future features, there is a challenge because Adamant is really like last-minute idea within the project that we've done we did only a couple of months. And this is also my first software project. So at the moment, the code is really not maintainable. It's spaghetti code, and it's hard to add these like future features, right? One idea is to maybe use these long context LLM models to help with refactoring. And yeah, in this case, maybe we can use this Gemini, the latest version, that can accept like quite huge of code base, and combine with expert prompting, maybe for me, because I know what the codes do. And yeah, maybe we can improve the code base for Adamant. And I would also like to hear your opinions about this, if you have any experience. And yeah, just to summarize, so we use Adamant to get human and machine readable experiment metadata based on these JSON schemas. We can use Flask API to connect to different RDM workflows. And I just said this feature works, that I don't have to repeat it again. And maybe just to advertise a little bit, we have a workshop going on soon in May. So it's going to be, it's about fair data in plasma science. It's probably quite relevant for other fields as well. It's going to take place at the University of Kiel, but it's also online. So yeah, can only like advertise you this workshop if you're interested. Yeah, with that, thank you very much for your attention and looking forward to your questions.